A computer program is just a neat little machine. There is nothing mysterious about it, because you are responsible for the machine architecture. You sit down with a pencil and a piece of paper and you scribble it out. The most flexible invention you can use to create machine-like behavior without much trouble is a tree of things that contain other things. In the world of programming, we refer to things as objects. So, nested objects. The object at the very top accepts the first set of sub-objects, and then all the sub-objects accept more objects. You can imagine the object at the top as a desktop or a window or the frame of a word processor page, as the case is with web pages. And then you just add more stuff inside the other stuff. And voila, you have a machine, a weird processing plant, or some assembly line. To make it move, you create commands, such as on data, send data to all other sub-elements. And this would actually create a waterfall, right? Because all elements are nested. So you would have a waterfall of data falling over all your tree nodes. So, objects washing over objects. That's a machine in the world of programming. Then you can filter things or transform things. You can, for example, filter for user objects, or filter for bad passwords, or listen for various happenings on nodes with a specific purpose. Happenings are known as events, and we say that a button within a form can emit an on-click event. So a save button would be configured to emit a save event that would likely include all the form information that the user plugged in. And sure, you can cross all things up and add the nodes upside down and sideways, but then you won't be able to imagine what the machine looks like in your imagination. And that is called spaghetti code. Basically, an unreadable mess that may even work, but because it lacks architecture, a sturdy vision or theory, it is trouble. It's hard to service spaghetti code, so no one really does it. That's why computer programming is not really that confusing, because everyone is always clinging on to some theory of operation, such as the tree I described above. When you are ready to write your big program, you first imagine a machine of how everything flows within it. Maybe you won't like trees because they are quite recursive. Then you may like pipes or circular assembly lines, where you put a command on the line and the command will change something somewhere predictable. Maybe the username of a logged in user, and then that change will trigger a user interface refresh or update. Usually it is nice to start with creating a hierarchy of objects and then just responding to the things that they do. It is of some note that your home directory is a tree, and then you have commands that cause updates and make things refresh. The old way of programming used to be about defining functions and then calling them. This is still commonly used for low-level stuff and commands. Take a look at FormMail, a Perl program. You should learn JavaScript though. You can see how functions are being called right beneath the header. And then below those initial calls, they are all spelled out or defined line by line, often including reusable helper functions. That is also a little machine, though not very much of a branching machine like the tree. But, still, a call is made, things get done, and the program execution returns to the next line, ready to make the next call. It's a machine, if you ask me. In object programming, you get to create concepts on top of functions. For example, a count. And then you attach your functions to that. So it's not just a function call, but a call for action made in context of something else. Very often a representation of a specific account linked to a specific user. A nice example can be found in Dream code, where you say account.signup and then pass in an object that has a username and password. Very nice to read, very rational. Here the account object or instance of an object groups account functions. But there are other groups in there as well. Data, email, sharing, files, payment, and make coffee or tea. I think the neatest example of a nice little machine is the web server. When you want to pull up a page in your web browser, a function inside the web server will receive two objects. Your request with the URL information and your internet address and such, and then a blank response that you must then customize with stuff in it. So if it so happens that you misspelled your password, you would write into the blank response .body equals wrong password. The most magical machine may just be the event emitter. The event emitter listens via .on function that specifies a specific event name. You can say save button .on click application .emit save. And somewhere in your application, you will have a save listener that upon getting the event save, will save a file to disk. Finally, you are probably wondering, how the heck do I save a file to disk? But you don't. That is something that your programming language will take care of and present in a really nice and convenient wrapper, most often referred to as a built-in function. And those are built on top of the operating system features, which then build atop drivers and microprocessors and computer hardware. So, to save a file, you look at the programming language's manual and see what you need to call. It will often be write file, then file path, and then some string of text that you want to put in that text file. Programming languages are made by people for people, by experienced and wise programmers, for programmers who are always in a hurry and need to get stuff done in a jiffy. So the world of programming is an inviting masterpiece of art, as great as all the galleries put together. And when you become a programmer, you are rarely confused and certainly never overwhelmed, because you are the architect in charge. You are inventing both the machine and the tools that keep it going, that keep it clear, that invite others to participate in the development of your program.